Okay, so today we are going to take, I guess this is spring 2022, this is exam 2, and this will hopefully be a reasonable facsimile of a key. Okay, first problem, determine the reactions at A and E for the following structure. I don't know why, I should have put 1 and 3 next to each other. I don't know why they ended up being not next to each other, because clearly they're the same problem. Anyway, so this one, what I'm going to do is I'm going to draw a free body diagram here. Just because it's gonna, it always helps. So basically, I'm gonna cut away the world. I'm gonna cut away the world at this pin at A and at that roller at E, right? So, that hopefully will make this kind of make sense. So I guess in red, I'll do my forces. Right, so this is 150 pounds. I've got E, which I'm going to assume is upwards. I think that's correct, right? It's a roller. And then I've got A, which is almost certainly going to be in the opposite direction, but we'll go ahead and draw it here as AY. Whoops. And here's AX, which will almost certainly be going to the left. But I'm just going to draw it positive for giggles. Okay. And I guess, we need some dimensions here because that is totally going to help. And, which ones do we need? Well, okay, well, let's just say like this right here. This is 2 feet. All right, this is 60 degrees. This is 60 degrees, which of course means that this is an equilateral triangle. Which means if it's an equilateral triangle, then that this right here is 2 feet. Okay, because it's an equiliteral triangle, so all the sides are 2 feet. Okay. Now, of course, one of the tricks here, of course, is that this force right here, this is a 0.5 feet from there. So that means that there's 1.5 feet left here. Okay. So that's going to be important. I think that's it. Okay. So let's go ahead and let's solve this sucker. And we'll just go in order, right? So we'll just do, okay, the sum of the forces in the x direction equals 0. Well, I guess in order by, which one, we've got one unknown in the x direction, and that's AX. So I can say, well, AX plus that 150 pounds equals 0. So AX equals negative 150 pounds. Okay, cool. Okay. If I did the y direction, there's nothing wrong with that, but notice we've got 2 unknowns in the y direction, A, Y, and E. So I'm going to avoid doing the y direction just yet. And I've got enough room on the right, so I'll just go ahead and do the sum of the moments. Sum of the moments equals 0. And I want to pick a point that's going to make this solvable. And really there's 2 points right here. So if I chose E, then that would get rid of E would have no moment and AX would have no moment. But I don't want to do E because, I could do E. It doesn't matter. I think most of you are going to choose A, and that's where I tend to choose either as well. It's neither better nor worse. It's just it's just another location, right? And so I'm going to do this with A because I think probably most of you guys did it at A as well. Okay, that meant that both AX and AY go away, and I'm left with E. So this force right here, E, its moment arm is, that's the right angle distance. That's 2 feet. Okay, and it's causing things to spin that way around A. So if we draw this, that's a positive sign. Okay. And the only other force that I have is this 150 pounds. And its distance is a little bit, weirder, I guess. So its perpendicular distance, well, let's see. The force is going to come back this way, like that, right? And then, so the distance is going to be like this, right? So that's a little bit annoying. Right, so basically what I'm looking for, let's see, maybe I can do this in black. I'm looking for this distance right here. So here's my triangle. Right, I've got 1.5 on the hypotenuse. So 1.5 times the sine of 60 is going to give me that side. Okay, so this is going to be 1.5 feet sine of 60 degrees equals 0. Okay, now what direction is that going to cause things to spin around A? Well, it looks like it's going to go this way. So that's going to be a negative sign. Okay, so if we solve this equation, we get E equals, 97.4 428 pounds. Okay, so that's keeping the Sig Figs. Okay, and then let's see here. So now we need to do sum of forces in the y in order to get the AY. Okay, so we'll say, okay, sum of the forces in the y equals 0. So I've got AY is going up. I've got E is going up, equals 0. So now I'll plug in the value for E from right here. So we'll say AY plus 97.428 feet, or pounds, excuse me, equals 0. So AY equals 97.428 pounds. Oh, sorry, negative. Okay. So down here, and this is kind of an interesting thing, I probably not even going to take off for the signs here because, you know, looking right here, I just asked for the magnitude. If I'd wanted the signs, I should have put that on there. Oh, and it looks like I gave you an EY, and we'll just call this, I guess this is EY right here. But, you know, if I wanted the signs, it would be 97.4. Because part of this is, you know, when you go back and you do this problem in a second, you know, you're going to have to know the direction of those. Okay, so you would have to prove to me a direction. Anyway, so those are them as vector quantities. If you wanted them as scalar quantities, I mean, I guess technically it would be like this: I, J, J. If you wanted them as scalar quantities, you just do 150 and 97.4, 97.4. Okay, I haven't decided how I'm going to grade those points. I guess I'll go over that when class time comes. Okay, this one, using the method of sections. Okay, so that's annoying. We have to use the method of sections. Determine the forces in members. Let's see here. BD is right here. DE is right here. And EG. So one nice thing about this is that all three of those members none of them are at an angle, right? They're all either vertical or horizontal. So that's nice. The other nice thing about this is I don't have to do the reactions if I don't want to, if I draw the top half of this. Okay, so that's exactly what I'm going to do. We'll draw a free body diagram of the top half. Okay, so there's the top half cut in the locations that, you know, I just mentioned. Let's give some locations. You know, this will be A, B, C, D is over here, right? It's like not even you know, in our drawing. And here's E, right? So now we need some forces. I'll go ahead and make them red. So I've got P in both of these locations. We said it's 600 newtons, so I'm just going to go ahead and write it as 600 newtons. 600 newtons. And that's it, right? And so now I have to do the forces where I cut it, right? So we've got a force right here, which I'm going to call EG. I've got a force right here, which I'll call DE. I like to go alphabetical order. This will be BE. Okay, that also matches what I did up here, so that's a good way to do it. Okay, once we've done this, it's exactly the same thing as we just did. Just, you know, it's just a section instead of the whole thing, right? So let's see here. In the vertical, or let's see, the horizontal is the easiest. So maybe we'll start there because we only have one unknown, and that's DE. So the sum of the forces in the x direction equals 0. So I've got, let's see, I've got two of those 600 Newton forces. And then I've got minus DE equals 0. So DE then is 1,200 newtons. Okay, and that's, oh, I wrote pounds, of course, because I'm an idiot. You know, these careless errors, they get us all, right? So there's DE. Okay, and that's a positive, so that one's going to be in tension. Okay, the vertical, I don't want to do the vertical just yet because there's 2 in the vertical, so let's do the sum of the moments. We'll pick a point. And again, there's 2 points that make sense. If I do that one, if I do E, then both EG and DE are going to disappear. And so there's nothing wrong with that one. However, well, that's probably the one most of you guys did, actually. Which one did I do in my key? I mean, the key I did D. So maybe just to be different on this one, I'll do E. Okay, so D is also, this is also a perfectly good spot because DE and BE will both disappear. It doesn't really matter. Let's go ahead and we'll do E just to be different than the published key. Okay, and so around point E, this has no moment arm. DE has no moment arm. BE, however, does have a moment arm. So let's do BE. Okay, now what's its moment arm? I didn't write any of the distances down yet, did I? Okay, let's go ahead. This is 4.5 meters. This is 2.4 meters. And this one right here is 2.4 meters. Okay. So, BE, right, if I kind of extend it down here like this, right, then its moment arm for BE, right angle distance, to E is 4.5 meters. Okay, so we'll multiply that by 4.5 meters. Okay, and now we need to think about, well, what direction is that causing things to go? It's causing things to go that way, which match our little positive, so we get a little positive right there. Okay, now we're going to get the 600 newtons, which is right here. Okay, and so if I kind of extend that one this way, okay, what's its moment arm? Well, its moment arm is going from E up till that line. Here's the right angle distance. So that's 2.4 meters. So that's going to be 600 newtons is the force times its moment arm, which is 2.4 meters. Okay, and that's causing things to go this way around. So that's a negative. Okay. And then we have to deal with this 600 newtons. And again, we're going to kind of like extend it out this way. Okay, and recognize that its distance is 2.4 meters plus another 2.4 meters, both of those. So that's 4.8 meters. So 600 newtons times 4.8 meters equals 0. Okay, and we have to think about the direction. So that force is going this way, so that's a negative direction. Okay, and if we do the algebra on this one, we will get that BE equals 960 newtons. Okay, BD. Oh, dadgummit. BD. Okay, this is BD. Sorry about that. Let's see, this is BD. BD. Okay, sorry. My apologies. Okay, so BD is 960. Notice it has a positive sign, so that will be tension. Okay, and then at this point, we can just do our verticals, which are going to be sum of forces in the y direction equals 0. And we can actually see all the forces right here. It's BD and EG. So I'm going to say BD, negative BD, because it's drawn downwards here, minus EG equals 0. So negative, I'll plug this number in, negative 960 newtons minus EG equals 0. And if we do the algebra there, EG equals negative 960 newtons. Okay, so that means this one is actually in compression. Okay, so we go over here. I want 3 Sig Figs. I mean, I'll be a little loose here on how you report these because, I mean, probably the best way to do this would be, scientific notation. But anyway, so BD is, let's see, that's BD. It's a positive sign, so that's in tension. Oh, BD, tension, DE, tension, because it's a positive sign, and EG, compression, right? And so then 960, I'm putting a little dot there to, end my Sig Figs. And those are in newtons. And for this one, probably the easiest way to get 3 Sig Figs would be 1.20 kilonewtons. Okay. Anyway. So there you go. That's it. Yeah, I think that's it. Okay. So scrolling down. Okay. This one's a little bit ugly or potentially ugly. So what we're going to do is we're going to use the reactions from part 1. If you used a different reaction, that's fine. Like, because, if you couldn't solve number 1, make some reactions up. Totally fine. So AX is going to be, obviously this potentially could create a grading nightmare, but that's okay. So I think maybe what we want to do is we'll draw a free body diagram of the whole thing, and then we'll start kind of pulling it apart. Okay, so let's I don't know. Here we go. I think maybe we don't. Okay, maybe we do this, and then we'll draw the free body diagram of the parts. Okay, so this is 97.428 pounds. This is 150 pounds. Okay, these are just my answers from the first problem. Okay, and this is going to be 97.428 pounds. Okay, so what we want to do here is, so the first thing we need to notice is, let's see, what are we looking for here? Oh, the magnitude of the forces in each joint. Okay, so we've got joint, I guess these are the joints B, D, and C. And each one presumably has an X and a Y, right? B, D, and B, C, and D. Okay, and I've written it with an X and a Y. The problem here, of course, is that this one right here, let's see. This is not a two-force member right here. Notice it's got 3 connections. Okay, this is not a two-force member. It's got 3 connections. I mean, if you want to call this pin a connection, I guess. Well, I guess it is. And it's also got this extra force on it. So we have to use the method of members. BD is a two-force member, which means BD can either be in tension or compression. And because it's flat, that means it has no vertical forces. So BY and DY are both going to be 0. Okay, so that's the quickest thing to help us out. Okay, the next thing we want to do is we want to kind of split this thing up and draw free body diagrams of its pieces. Now, one of the things that can make your life a little easier here is if you focus, you just figure out which one's going to be easier to work with. There's a temptation to say that this one will be easier to work with because, you know, I don't know, it doesn't really, I mean, I guess here you've got the same 2 forces here as you do here, but the difference is that these 2 are both happening at joint A. So that's probably going to make A, B, C easier. And so that's the one that I'm going to do. Maybe I'll do the other one. You know, and if you don't want to see both, you can just, you know, kind of skip over this part of this problem. Yeah, it also means I don't have to figure out any of the geometry of this one right here, although we already did that earlier, so it shouldn't be too bad. Okay, so I'm going to draw a free body diagram of A, B, C. Okay, and then we're going to go from there. Okay. Oh, well, I guess one thing I'll do real quick. Well, I'm just going to do free body diagram of ABC. Okay, so I went ahead and drew the free body diagram of both of these, and you know you can work with whichever one you feel more comfortable with, or you know both, or you know whatever. I didn't finish the free body diagrams yet, though, right? So if we look up here at this joint ABC, we'll note that there's a connection from B to D. And so there is there's something right here at B, and we'll note that there is no Y component because BD is a two-force member. So we're just going to draw that force, and we're just going to pick a direction. So I'm going to pick a direction like this. I'll just call that BX, right? Now, because I know that B and D are going to be equal and opposite, right? So I'm just going to go ahead and put this as DX. And I know that those two are equal to each other because it's a two-force member. If I get a negative sign, then that means, like I've drawn it as if member BD is pulling, ABC and CDE together. But if I end up getting the wrong sign, well, then that just means they're in the opposite direction. So anyway, and then so we'll go up to joint C. And again, the only thing that's important about joint C is that whatever I put on one of them has to be the opposite of the other one, right? So I'm just going to do CX here and CY here. And I'm just, at this point, I'm kind of just following the decisions I made when I made my key. And I don't think this is really all that critical. I can't really think of a reason why it should be one way or the other. Just that CY here is the opposite of CY there, and CX here is the opposite of CX there. Okay, so once I've done that, I'm just going to stare at one of these and decide which one of these is easier. As I was saying earlier, I think this side is a little bit easier, so I'm going to do this one. And I'll do the other one too, just to either ascertain my answers / in case you decided to work the other half and you want to see that solution. Okay, so let's see. In this one, this is just like once you get here, it's just like the last two problems. It's like, oh, well, I just need some forces in the x, some forces in the y, and some in the moments. Okay, in this case, the x's are a little bit annoying because cx and bx are both in the x direction. However, the y direction is easy, so let's start there. Sum of the forces in the y direction equals 0. So I've got cy going up, and I've got this 97.428 pounds going down equals 0. So cy equals 97.428 pounds. Okay, boom. Cool. Okay, now let's see. In the x direction, not so easy because I got cx and I got bx. So what we'll do here is I'll go ahead and I'll do the sum of the moments. Okay, I'm going to pick a good location. This is a tempting location. However, it's going to have, I'm going to have a moment for BX and CX right there, so we don't want to do that. So instead, we're going to pick location C, okay, because that's going to rule out CY and CX, okay. So now that means that we're going to need some distances here, which I haven't quite gotten to just yet. So let's go ahead and let's draw some triangles. I'll just do these in, I don't know, blue right here. So here's a big triangle. Oh, geez, my ruler slipped. Apologies for that. Okay, so I've got a hypotenuse of 2 feet. I've got an angle of 60. So this whole thing right here is going to be 2 feet times the sine of 60. Right? And then this little half right here, this little bit right here, if I go from here to here, that's going to be, okay, if I look at this little triangle right here, this little bit is going to be 1 foot sine of 60. Okay? So let's start getting those moments. So we'll start at, let's see here, where's my black? Okay, so let's start, here's BX. Okay, BX. Okay, let's draw this little thing to help us figure this out. So it looks like it's going to go around C. It's going to go, that's a positive direction. Okay, and its moment arm is this little right angle distance right here. Okay, so that's 1 foot sine of 60, 1 foot sine of 60 degrees. Okay, and then I've got this 150 I have to deal with. Okay, and it looks like it's going around this way. So that's going to be a negative sine, 150 pounds. Okay, and its distance is 2 feet sine 60. 2 feet sine 60, right? Because if we back that up this way, okay, here's its right angle distance is this line right here. Okay. And then we still got this 97 we have to deal with right here. And let's see, that 97 is going to cause things to spin that way around C. So that is a positive 97. 7.428 pounds. Okay, and its distance, if we kind of draw that line up here going like that, here's its perpendicular distance, is the bottom of this thing right here, which I didn't solve for, which I should have, I guess. It's got a hypotenuse of 2 feet. In this case, that's a cosine of 60 because that's the adjacent side. Okay, so this would be 2 feet cosine 60 degrees equals 0. Okay, so that's a bit of a mess, but that's what calculators are for. And if we use our calculator, we get that the b in the x direction equals 187.49998 or something. So like that. Okay, so there you go. Okay. Okay, so that's bx. And now we need to sum forces in the x direction. And in the x direction, we've got this 150, we've got this bx, and we've got the cx. I've completely obliterated my free body diagram, haven't I? Sorry about that. Okay, so sum of the forces in the x direction equals 0. And so we've got, let's see here, negative 150 pounds plus bx minus cx equals 0. Okay, so let's negative 150 pounds plus 187.50 pounds minus cx equals 0. So looks like cx is going to be positive. No. Yeah, cx is going to be positive, isn't it? So it was drawn the correct way, and it looks like it's going to be 37.500 pounds. Okay. So let's see here. So cy then is 97.4 pounds. We're just looking. So this is an interesting. In these problems, you're always just looking for the the scalar value, the magnitude of these forces, because we're not worried about the direction, because if it's positive in one joint, it's negative in the other, so it's not really important. So this is going to be 188 pounds. Okay, cy, wait, we already did cy. Cx is 37.5 pounds. Okay, now dx is interesting because the thing we know about dx is that bx and dx, well, it's a two-force member, right? So whatever one of them is, the other one is as well. So dx is going to be the same as cx, which is 37.5 pounds. Okay. Technically, they have opposite sign, but we're not really concerned about that because, we're just not. So I did that wrong, didn't I? It's supposed to be the same as bx. My apologies. Okay, so, right, so this should be 188 pounds. Sorry. Okay, I'm going to go ahead, if you want to skip forward because, you don't want to see this done twice, that's fine. But what I'm going to do right now is I'm going to solve it, assuming that you decided to do this side first instead. Okay, so if we were to do this side, who knows, it might be easier. Yeah, I don't know, we'll see. So anyway, so what we would do here is we would note that the x direction is not as easy as the y direction. So let's go ahead and we'll do the y direction first. So this is not necessary. You would only do this if you hadn't done ABC instead. Okay. Or if you did all of ABC, you wanted to check it, you could go to this side. Or if you did all of ABC and it didn't quite solve everything for you. Okay. So here we go. So we're going to go in the y direction. Sum of the forces in the y equals 0. So I've got negative cy plus 97.428 pounds. Those are my y forces, equals 0. So cy equals 97.428 pounds. Boom. Okay, we're good with cy. Okay, now we need to do the moments. There's really only one place where the moments make sense on this one, and that's right here. Okay, because that's going to get rid of cy and cx. So we'll go sum of the moments around C equals 0. Okay, and it looks like every force that's not at C is in play. So I'm going to have a 150. Let's draw this little doohickey. So I've got a 150 pounds, okay, times its moment arm. I've got dx times its moment arm. And I've got that 97.428. 97.428 pounds times its moment arm. And all that's going to add up to 0. Okay? And let's think about the directions for all of these. The 150 is going this way around cx, so that's a positive. The dx is going this way, so that's a negative. And the 97.428 is going this way, so that is a positive. Okay, so we got the signs. Okay, now we need to work on the moment arms. Okay? So these are all just signs, signs and cosines and things. So let's see here. For the 150, here's my perpendicular distance is right here. Right? So that's that distance is going to be, let's see here. Let's just scroll in on the thing here. So this is for the 150. I'm going to end up with this distance right here, which is, let's see here, we have a little triangle. Right? This is a 60-degree angle. The hypotenuse is a half. Okay, so this is going to be 0.5 times the sine of 60 degrees. Okay, for dx, let's see if we can get a different color. Okay, here's the force. Here's the distance. The perpendicular distance is right here. So that distance is going to be 1.0 times the sine of 60 degrees. Okay, and then for this 97.428, here's the force. Okay, so its perpendicular distance is right here. Okay, let's see. And so we'll need, so this angle is a 60-degree angle right here. The hypotenuse is 2 feet. So this distance is, this distance is going to be 2 feet. 2 feet. And this is the adjacent side, so cosine of 60 degrees. Okay, so that's how we get all of those distances. Okay, so that's this distance right here. Okay, so if I'm gonna kind of scroll out so that I can see those as I write them in. So for the 150, it's 0.5 sine of 60 degrees. For the dx, it's going to be 1.0 sine of 60 degrees. And for the 97, it's going to be 2 feet cosine 60. 2 feet cosine 60. Okay. Anyway, so that's basically how we do this. Let's erase this and put a little 7 right here. Come on, you can do it. little 7. And we'll go ahead and solve this bad boy, or girl. This is, an equal opportunity classroom. And let's see what we get. Okay, plugging all that into the calculator, we get 187.5001. So 187.50 pounds. Okay, I believe that matches what we did earlier. I guess we'll check it in a second. We're going to pretend we didn't do the stuff earlier. Oh, dadgummit. Just cheated, sorry. All right, so then we can do the sum of the forces in the x direction. Okay, so in the x direction, we've got cx right here, cx. We've got dx right here, minus dx. And here's the 150, sorry, plus 150. Okay, so for dx, which I got a positive sign for, which means we're just going to plug it in as is, minus 187.50 plus 150 pounds equals 0, and we'll get cx equals, looks like it's going to be 37.500 pounds. Okay, so these answers, I believe, match the ones from earlier, right? So let's see here. So cy goes right there. Dx goes right there. We're looking good. Cx goes right there. And, of course, cx and dx are the same, so those match up. Okay, so yeah, so this is good. Okay, so you could have done it either way, or you could have done it both ways to check your work if you had time. I don't think anybody really had enough time to do that, but we'll see what happens. Okay, so the last one. Okay, the 3 vertical wires support the 16-pound square plate. Okay, so we need to put that weight on there. It's going to happen right here at the centroid. Right, 16 pounds. Oh, not 60, 16. Okay, so we got 16 pounds going down. And I've got these 3 forces going up, like that. So, TB, TA, TC. This is one of the few times when really using the drawing works out really well for a free body diagram. Determine the tension in each wire when A equals 10 inches. So I wish there was a way I could erase that A and put in like a 10 inches. I guess that works pretty well. Oh, not pounds, inches, you punk. Sorry. All right, so I'm going to show you real quick. Maybe I'll show you. Yeah, I'll show you the quick way. No, I'll show you the quick way later. I'll show you the way that I expected probably most of you guys would have done this, which is that, let's see. So in the, if we think about our three equations, right? I'm not going to draw a separate free body diagram because this pretty much is a free body diagram. It is a free body diagram. It doesn't have anything extra on it that would make it not a free body diagram. It just so happens that in this case, it's rare for this to work, but it does. Okay, the other thing to be aware of here is that this 16 is, from the walls, it's, 15 inches in all directions, right? 15 inches, 15 inches, right? Not pounds, inches, you punk. All right, so anyway, so let's, so one of the things I would have expected is you would have said, okay, well, we've got a lot of equations here, right? Because this is the 3D problem. So I've got some forces in the x. So here we go. Let's just do forces. Some of the forces, x, y, z, and let's see if any of these are useful, right? In the x direction, there's no forces, so completely useless. In the y direction, well, we've got forces, but we've got 3 unknowns. Okay, so that's useful, but kind of hard, right? In fact, off the top of your head, it seems, straightforward. Got 16 pounds pulling down, and I've got 3 TA plus TB plus TC going up. So useful, but insolvable at the moment. Okay, in the z direction, we have no forces. Okay, so the unfortunate thing about that is that means that we have to go into moments first. Okay, and I could do, x, y, and z. For you guys, I'm not sure that, some of you guys have the vision to see how to do that, and I'll talk about that in my shortcut in a second. But, usually this kind of means that let's just kind of focus on, finding the moments from each of these cables, okay? And so, so again, there is a quicker way to do this, and I'll do that in a second. I'll kind of do that over here. So this will be like the quick way, which I realize I didn't really teach you guys the quick way. I mean, maybe you won't like it. Anyway, so I'm going to do a moment, and I'm going to choose as my center point for the moment A. It doesn't have to be A. You could do B or C. I just think it's going to be easiest at A because the geometry is the cleanest. So that's where I decided to do it. So we'll do the sum of the moments, not the sum of the moments. We're going to just, I mean, that is what we're going to do. But first, I'm going to isolate the moment at A due to the force at B. Okay? And the way we're going to do that is we're going to do I, J, K, and then here's another I, and here's another J. Okay? So we need to do the R first, and then we'll do, so the R is like right here. You know, it's going from A to B. So that's the first R, right? And how far, what is R? Well, we're going to go, it looks like we're going to go 10 inches in the X direction. So 10 inches in the X direction, and then we're going to go 30 inches in the Z direction. And we don't go in the K direction. Okay, so then I'm just going to copy that over here, like that. Okay, and then, let's see, and then the force for TB, luckily the force is pretty straightforward, it's just a vertical force. So we're just going to go TB right here. And that's not in the X or the Y direction. So let's go ahead and take the determinant of this matrix. And so we'll do that by, we'll start, we're going, okay, that's a 0, that's a 0, here's a value, right? 10 inches times TB times K. Okay, so because I kind of have some idea the way this is going to look, I'm going to do MA comma B. Well, you know what, let me do it over here. MA comma B equals, I'm going to leave some space for the I value and for the K value, right? And this is me cheating a little bit. I know I'm not going to get any J values. But anyway, so for that one, that's going to be 10 inches times TB times K. Okay, and that's a positive number. Okay, and now I'm going to go back and I'm going to do my negative thing. So this is a 0. This has a value, and that's going to have a negative number in front of it because we're going to multiply the whole thing by -1. So negative 30 inches times TB. Okay, and then let's see, and then we got one more, which is also a 0. Okay, so that's cool. All right, so that's the moment due to moment at A due to B. Now we're going to do the moment at A due to TC, right? So moment, I didn't want a different color. Let's go with black again. Give me that black, okay. M at A due to C, okay, and I've got I, J, K. Okay, and now we need that R, okay, and maybe we'll do the R in blue so we can see it. So we're going to go from A all the way out to there, and so what's the R? The R is in the X direction. Well, we went 30 this way in the X. And then the Y, we didn't go anywhere. And then in the Z, we went this far, 10 inches. Okay, and then again, just like in the last one, the force itself is relatively easy. It's just in the J direction. So this is going to be TC, 0, 0, 0, TC. Okay, and here's my I and my J. All right, so again, I'm going to do MA due to C equals. So if we start calculating this, really the non-zero values are right here and right here. Okay, all the others are 0. Okay, so so this one gets multiplied by a positive 1. Sorry. Yeah, that's right. It gets multiplied by, is that right? Yeah, that one gets multiplied by a positive 1. So for my K's, I'm going to have 30 inches times TB, excuse me, TC. Dadgum TC. All right, so TC. And then for my, this one gets multiplied by a negative number. So I'm going to have negative 10 inches times TC. Okay, and that's got the I on top, right? Okay, so we're getting there. Let's see, I've got another force I need to deal with, which is this 16-pounder right here. Okay, so I'm going to call this the moment at A due to the weight. Okay, and it's going to be I, J, K. Okay, and here we go, I, J. Nope, not K, I, J. Excuse me. Come on. Come on, you can do it. I hate when it freezes like this. Okay, here's J. All right, so again, we need the R thing, and I'll do that in like green. Maybe that'll show up here. I think it's probably showing up. So there's R. And you got to go 15 in the X direction and 15 in the Z direction. So this is going to be 15 inches. This is going to be 15 inches. This is going to be 15 inches, and this is going to be 0 and 0. Okay. Now, again, just like the other ones, the weight is only in the K direction. Only in the Y direction. And it's going to be a negative 16 pounds. Negative 16 pounds. Okay, negative 16 pounds. And everywhere else, it's zeros. Okay, so solving this, I'll solve this as MA due to the weight. Okay. And we're going to end up with, let's see here. Again, I guess just like in the last one, here, this one right here. Okay, that one gets a positive sign on it. It gets multiplied by positive 1. So 15 times negative 16 is, I think, 320 or 240 or something. Hold on, I have a calculator. Wait, hold on. 15 times 8 is, 15 times 4 is 60, times another 4 is 240. Okay, so this is a negative 240. Negative 240 inches, pounds. Okay, and then, let's see here. And then in the I direction, we get this one, but it gets multiplied by a negative 1 because the slant is backwards. So we end up with a 240 inches, pounds in the I direction. Okay, so there you go. So that's it. Okay, so what I want to do now, obviously, or what would really be nice is I want to get to this equation right here, but I can't just yet. I need to do these moment equations, and the moment equations, I'm basically just gonna add up all my moments. Here's one moment equation. Here's another moment equation. So the sum of the moments basically has to be 0 and 0. Okay, in the I direction and the K direction. Now notice there is no J direction for the moments. Okay, which means really that if I go up here and I'm thinking about my equations in the J direction, this one's useless right here in the the quote unquote the Y direction, and I'll have once this thing unfreezes, so I can actually write the X mark that I'm planning. So right here we can't use that one. In the X direction, look, we've got two unknowns, TB and TC, and in the Z direction we've got two unknowns, TB and TC. So we got TB and TC. TB and TC. Okay, so basically we're going to have to solve these two together. So I'm going to go down here, and so I've got one equation, so this is one equation right here, so that all of those things add up to 0. So negative 30 inches times TB minus 10 inches times TC plus 240 inches pounds equals 0. Okay, that's one equation. And then I've got a second equation right here, which is this. Those are all my K's. So I've got 10 inches TB plus 30 inches TC minus 240 inches pounds equals 0. These are very similar equations. As you can see, and really the reason for that is because of the symmetry of this problem. Like if you look up here, you should note, or hopefully you can see that I could draw a line of symmetry right through here, and everything's symmetrical left to right. And because of that, and I'll talk about this in a second in the quick way, which is that TB and TC are equivalent to each other, or equal to each other, okay? But anyway, let's suppose you didn't notice this was symmetric. Well, what you'd have to do is you'd have to solve one of these equations for TA or TB and plug it into the other one, okay? And I'm going to start, it doesn't really matter which one you do. I'm going to go ahead and do this one on the left. And so what I'm going to do is I'm going to say, I'm going to bring that 240 over. Well, one thing I'm going to do is I'm going to divide them all by inches, so those inches are going to go away, because I don't feel like writing that a million times. So negative 240 pounds. And then I have to figure out which one I'm going to solve for. I think I'm going to solve for TC because it's got the smaller coefficient. That means that when I divide, I don't end up with a fraction. So anyway, so then I'm going to bring that 30 over plus 30 TB. And we'll leave this over here. So I've got negative 10 TC. Okay, and then I'm going to divide both sides by negative 10, and I get TC equals, looks like it's going to be 24 pounds minus 3 TB. Okay, and that's nice and clean. Okay, so then what we'll do is we'll plug that in over here. And so again, well, before I even do that, I'm going to cancel all these inches because I don't feel like dealing with inches. And since they're all in inches, it'll work out. So I've got 10 TB plus 30 times TC. But in place of TC, I'm going to write 24 pounds minus 3 TB minus 240 pounds equals 0. And of course, this is just, algebra being, a little bit annoying. But let's see here. 10 TB plus, 720 pounds minus 90 TB minus 240 pounds equals 0. Okay, if we collect like terms and do all of our stuff, whatever, TB then equals 6 pounds right here. And then, of course, the easiest way to get TC would be to plug that back in over here. And so we'll say, well, TC equals 24 pounds minus 3 times 6 pounds, and TC equals 6 pounds. Okay. By the way, this was a little bit contrived. I stole this from the homework. Yeah, so anyway. So we've got these two, and now we need to get TA. So let's see, TB is 6 pounds. TC is 6 pounds. How do we get TA? Well, what we're going to do is we're going to go up here to our 3 unknowns right here, because we, three equations, 3 unknowns. These are my 3 equations. And so in the y direction, sum of the forces in the y equals 0. So TA plus TB plus TC minus that 16 pounds of weight equals 0. So TA plus 6 pounds plus 6 pounds minus 16 pounds equals 0. And TA equals 4 pounds. Okay, so TA is 4 pounds. Okay, so that said, I'm going to show you the quicker way to do this particular problem. And so what I'm going to do, I think, first I'm going to, this may not be quicker initially if you haven't thought about these things this way. First I'm going to erase all this so that we can kind of get a clean slate here. Then I'll redraw this as a free body diagram by putting those forces back on there. So we've got, let's see, this is TC, this is TB, and this is TA. Okay, and then of course this is 10 inches, this is 10 inches, and I need the weight, which is right here, which is the weight. Okay, now what I want to do here is, okay, so the first equation, so the first thing that you note is, if you want to do this easy, is that you recognize the symmetry of this. If I draw a line from A to this corner right here, we know that everything is exactly identical. On the left hand is the right hand. And so because of that, TB must be equal to TC. Okay, so that's one thing. The second thing we want to do is we want to think about, as I was saying, like the 3 possible equations. We need 3 equations because we have 3 unknowns. One equation is the sum of the forces in the y equals 0, which means that TB, or TA plus TB, or really TA plus 2TB, right? Because they're both the same. Maybe I'll just call that T. So we'll say equals T. TA plus 2T equals 0. Okay, so that's cool. So now I need one more equation that is going to work with, that's going to help me solve for these particular, these T's, as it were. Okay, and so it's going to be a moment equation. It has to be a moment equation. And so what I would do here, you could do the X or the Z direction. And what I want you to do is I want you to think about perpendicular distances, okay? And so this is going to be kind of like the visual 3D, like moments, okay? And so what we would do here is we would think about, so let's just do the X direction. It doesn't matter which one we do, okay? So what I want you to do is I want you to think about perpendicular distances to that X axis. So we're going to do the sum of the moments around A, just like we were doing earlier, okay? But I'm just going to do the X direction, okay? So what I want you to do is I want you to think of your thumb, and your thumb is going, let's see if I can draw this. So here's your thumb, and then your fingers are curling over the top like that, okay, if this is your right hand. Okay, so that's your right hand, the thumb is going that way. And what I want you to picture is how each of these things is causing this thing to rotate around this location right here. Okay, this axis. Okay, because that axis is going through A. Okay, and so what you should note is that this TA right here, it's not causing it to spin in that direction, so it doesn't count. Okay, this T right here, it's causing it to spin this way, right? So that is the opposite of my fingers, so it's a negative sign. It's got a force of T, and then what's its moment arm? So then its moment arm looks like this. Okay, so here's the perpendicular distance, right? It looks like that, and it's 10 inches. Okay, I'm going to go ahead and do the other T since we're thinking about T's right now, and we'll note that the other T right here, T, give me black please. So the other T, okay, it's causing things relative to this axis. It's causing this whole plate to want to turn that way, right? So it also has a negative sign. And its moment arm, okay, that's its perpendicular distance right there. Okay, so that's 30 inches. 30 inches. Okay? And now we have to deal with the weight, right? So the weight, let's see. So we've got a weight, so that's the force. Okay, well notice that this weight relative to this thing is causing it to spin that way. So the same direction as my fingers. So that's going to be a positive for the weight. And its distance is right here. And that's going to be 15 inches. Times 15 inches equals 0. Oh, that weight is known, right? It's 16 pounds, right? Sorry. So this will be 16 pounds. Okay? So we can solve that for T, right? So we can go right here. Now, fundamentally, this equation, if you look at it, well, look, it's the exact same as either one of those, depending on, which one's TA and which one's TB, but it's the exact same equation, right? But if we go down here and we solve this, it's a little bit easier, right? Because I knew that this wasn't an A or a B, it was just T, but it's the same, right? So then I'd say, okay, well, negative T times 40 inches equals, I forgot what 16 times 15 is, 240, I think, 240 inches pounds. So if we divide both sides by 40 inches, we get that, negative, right? So we end up that T equals 6 pounds. So that's TA and TB. And then we can go up here and go, okay, well, cool. So, oh man, up here I screwed up, didn't I? I forgot the minus weight, minus the weight, because I'm an idiot. Okay, minus 16 pounds equals 0. And so what I can do is I can take this T and I can plug it in right in here. And then I'll get that TA equals 4 pounds. Okay, and that would be like the quick way. Okay, so so this is TA and TB. Okay, and that would be the quick way. Doing these 3D moments, the reason that I didn't ever teach you this method is that it's pretty rare in 3 dimensions to have forces that are in a single direction. Like these are all just in the J direction. So that makes this kind of visual moment finding much easier. Usually, of course, we've got forces in 3 dimensions that are going in all kinds of crazy directions. So in that case, this way is definitely the preferred way, and this way will always work. And so that's why that's the method I taught you. Anyway, so we're approaching an hour here, so I think that's it. I will be grading these for a lot of today, and hopefully you guys did well. All right, I'll talk to you later, and I hope this helped. And please take care of yourselves. Again, as always, way more important than anything we do in this class. All right, signing off. Bye.